All right, well, I think most people have probably filtered in. I know we have 90 minutes for the session. There is a lot of content, but I will try to leave some time for Q&A as well. So we might as well just go ahead and get started. So my presentation today is about Cumulus. It's a software project I work on, and we'll be talking about what it is and why it may be valuable for some of you here at ESIP. Before we dive into what Cumulus is, though, just who am I? I didn't change anything. Okay. Let me just make sure my audio is off on my laptop up here so that doesn't happen again or anything. Okay, it should be. That was weird. Hopefully, yeah, all right. Well, hopefully it doesn't happen again. Let me also make this full screen here on the presenting machine. Okay, great. So I am a cloud engineer at Development Seed. We're based in Washington, D.C. And I am also a member of the Cumulus core team. That's why I'm here presenting to you about Cumulus. And I'm a lover of dogs, hiking, and the Baltimore Orioles. I'm from the East Coast. So just a little outline of what we're going to be talking about today. Why Cumulus? Kind of where did it come from? And what is the value of it? What is it? How does it work? What's next for Cumulus? Where can you find it on the web? And there will be a live demo where I'll be showing you how you can use Cumulus, and then we'll have time for questions. So why Cumulus? Since 1994, the Earth Science Data Systems Program has committed to full and open sharing of Earth science data obtained from NASA instruments to all users. But in the very near future, the amount of data that's going to be coming off of instruments, specifically the SWOT and NISAR missions, that's what these two images here represent, is just going to grow exponentially. And you've probably seen this in other slides, and you're probably already aware of this, but this in general increased volume of significantly increased volume of data means that traditional methods of storing data become less efficient, start to make less sense. So there was a impetus to move to the cloud with this tremendous increase in data volume. And the specifically, this Cumulus is born out of the context of the NASA Earth Science Data Systems ecosystem, where we have the DACs, who are actually responsible for carrying out the mission of providing the Earth science data. So, you know, ESDIS has the mission of providing the public Earth science data, but the DACs are responsible for different domain, managing and providing access to different science domain-specific data. And several of these DACs are already using Cumulus to some extent. The Physical Oceanography DAC out in California, the Global Hydrology Resource Center DAC, and some others will be coming online later this year. And in terms of where Cumulus fits in to the ecosystem of the NASA DACs, you know, so we have the data providers, the data is coming off of the instruments. Cumulus is either notified about that or polls to receive information about that. And then it stores, it transfers the data into the cloud and stores it. And the DAC operators are interacting with Cumulus to schedule and create the workflows that actually do the pulling of the data into the cloud and any processing of it. So they're interacting with Cumulus. Then you have the NASA, in this ecosystem, you have the NASA ESDIS services, which will, information about what Cumulus is holding, what data it's holding will be published to them so that people can search the holdings through those services. And then the data consumers will also come through those search tools and the same search tools and actually get access to the data for whatever they want to do. Yeah. So what is the value proposition of Cumulus? I mean, we're talking about a tool here that obviously is going to help you get your data into the cloud, which is starting to make sense more and more as we move to cloud native data processing strategies. But what's the specific value add of Cumulus? Cumulus enables science to happen in the cloud. So it's not just about data management. Obviously, Cumulus, what we're going to talk about is it does a lot of the heavy lifting for you with regards to your data management. But the real goal here is that we want science to start happening in the cloud. I mean, there's been presentations about Pangeo and other things which kind of are on the other side of the equation where we're making it easier for you to do that processing once the data is in the cloud, but we need to get that data there in the first place. So that's part of the mission that Cumulus is aiming to fulfill. The other thing is that Cumulus isn't just, it's not just about getting the data in the cloud. It's a kind of, we don't see it just as, data ingest or it's data stewardship. So it really encompasses all these aspects here that you see here. There's backup and recovery strategies, there's error handling, there's provenance, so you can know where your data came from. There's simple access to the data via an API, and then there's ability to report out metrics and other useful things. And this is kind of another diagram just to show where Cumulus sits in the kind of data lifecycle, where, again, starting from the bottom up, you have these data providers, and they have the data that was received from instruments. And then again, they notify Cumulus, or Cumulus pulls them somehow to be aware that there's new data. And then Cumulus, that big image in the middle there, is just saying that Cumulus does some stuff that we'll talk about in more detail to actually pull that data into the cloud, to run processing on it, to store information about it. Then again, it publishes out to some, in this case, this is the NASA ESDIS ecosystem. It publishes out to systems like CMR to make them aware of what data it has in its holdings. And so then at that point, it's kind of effectively part of the ESDIS archive. And then again, an end user would come through a search tool or other means and discover that data, and then they would be accessing it from Cumulus the storage in the cloud that is Cumulus is aware of. So again, the other thing here is that Cumulus is not trying to, and it kind of, the goal of Cumulus here is that we're trying to solve a lot of the cloud management for you in terms of data ingest and management, and then letting you do the pieces that are more science intensive, that are always going to be very specific to each domain. So even within the NASA DAX, the information they want to publish to CMR about their data is different, and so their tasks that can be plugged into a workflow are different. So Cumulus is really providing a foundation that you can build on, and then hopefully again enable science to happen. Kind of other more philosophical things about the project. So Cumulus is open source. There's a commitment to it being so it is an open source project, and I'll share the link later. So we want to involve the community. We want to have people using it and testing it and pushing on it. Ultimately, we think that's going to make better software. So also sharing and code reuse. So again, there's always parts of any data management that are going to be unique to the different data managers, but there is a lot of pieces, especially where it comes to just managing the workflows that do the data ingest or things like that. There's a lot of pieces that are at the same time reusable, and so as much as possible, we want to promote that. And Cumulus, again, is kind of an underlying framework that we have some pieces that we provide already for you to get you started, but the goal is to create this sort of ecosystem where people also contribute new pieces that others might find useful, which we'll also talk about a little more. Again, Cumulus is configurable, so it has a lot of these different pieces, and you may not need all of them. You may need, So you can configure what you need for your individual Cumulus deployment, and we'll also talk about that a little more and show what that is. And then common services I kind of already mentioned. So there's a core of functionality to Cumulus, but then you can build on top of that. So we provide enough for you to get started and to start ingesting your data into the cloud, but you can build on top of that. So it's also a collaboration. There's development seed who piloted the project, but at this point it's a collaboration of people who work on it and maintain it. And so we have development seed, we have Raytheon Element 84, names you've probably all heard, and then of course Estes. So we have our actual DAC users giving us feedback, of course, and also contributing some pieces that other people can use, like what I talked about before, themselves. And we'll talk about what are those actual pieces. Because of this, Cumulus is inherently not monolithic, or it can't be, because it has to be used by all these different diverse groups. Even within NASA Estes, the needs of different DACs demand that it be a system where it can facilitate different needs. And so that's part of what it being configurable is important for. So that's just sort of an explanation of the value of Cumulus, but like more specifically, technically, what is it? So Cumulus is a collection of resources for deploying and configuring a data pipeline in the cloud. So again, kind of keywords here are collection of resources. It's not necessarily a one thing. It's a collection of resources that you assemble into what you need to build the data pipeline you need in the cloud. And this is also just kind of underscoring that you have these different pieces. You have Lambdas, you have workflows, you have queues, things you're all very familiar with the cloud, and specifically AWS. And you configure Cumulus and you decide what pieces you want, and then you deploy it into your AWS account, is really all this is trying to show. So you have an instance of Cumulus yourself. And Cumulus itself, the Cumulus code that you find on the web is just the different pieces that you might assemble and configure into your Cumulus deployment. So again, there's not one Cumulus. There's just various different deployments that have been configured different ways using the packages that we provide and that others have provided. So some of the core functionality, this isn't an exhaustive list, but there's a rich API for triggering, scheduling, and monitoring workflows. So the actual workflows that do the ingest of data, that pull them from the remote data sources and pull the data into the cloud and run processing on them. We have a rich API for scheduling those. They can be triggered by different things. They can be run manually. They can be triggered by Kinesis streams or SNS topics. Again, there's a set of core tasks for workflows, so things that are going to be common across most data operators. For example, discovering your data from the remote data source is something that most people are going to need. So there's core tasks like that. It's built on an AWS serverless architecture, so as much as possible, no manual management, so we can scale as much as possible to facilitate these very high loads, and we're talking about with the increased data volumes that we're going to be having in the near future. And it also has data persistence and an API to access that. So again, it stores records about what has been ingested and the executions that were used to do those ingests, and you can interact with that data via an API. Then there's the configurable features. Again, there's VPC support, so you can run your Lambdas, your API gateway, your Elasticsearch, a VPC, and all the components will talk to each other properly. There's ECS auto scaling, so when you're building your workflows or your step functions, you can use Lambdas or you can use ECX activities, and then you can configure your auto scaling policy for when you should scale up to accommodate your demand from your workflows. CloudWatch rule triggers for Lambdas, and we even have some execution throttling. It probably sounds a little odd because most of the time we want to scale up as much as possible to accommodate the load of data we're trying to process, but in some cases, people may want to throttle. Maybe there's a limit on how many concurrent connections can be on a data provider or something like that, and so you can we have features that are configurable to do that. We also have a Cumulus dashboard. So I mentioned that we have this API about what data has been ingested and all of that. But then there's a dashboard, an actual GUI, a user interface, which I'm not going to talk about too much in the presentation because it'll be the main thrust of the actual demo. But this is just kind of a preview of what it looks like. And this is a kind of overall bird's eye view of a lot of the different pieces in a Cumulus deployment. On the bottom left is just talking about the tools that you use to deploy Cumulus, which is actually something that's probably changing in the near future. But in the middle is the actual pieces of Cumulus. So it shows basically how in the bottom there where it has a big box that says SQS, it's showing how work is scheduled by queues and then picked up by other Lambdas and actually run in sort of a fan out architectural pattern. And then it shows how information is written to SNS topics and then written to the database about what is being ingested both at the beginning and end of workflows. And then all of this data you can access via the Cumulus API. But the main task of a Cumulus developer, so like most of the boxes there that aren't in blue are kind of core functionality that you'll need, and that will be provided for you from Cumulus Core. But the main task of a Cumulus application developer will be to compose your actual workflows that are going to be doing the data ingest, the data processing out of the tasks that make sense for you. So using some of from Cumulus Core and also some that maybe you've written yourself. So that's going to be the main task of a Cumulus application developer. So again, more like specifics about what these core resources are. So most of the Cumulus core code is written in Node.js. So most of these are Node.js packages. So there's Cumulus deployment package, which allows you to configure and create a Cumulus deployment. There's the API package, which adds Cumulus API to both schedule and run your workflows, but also to access that data about what's been ingested in your metadata. And then, as I mentioned, the common tasks that you may use as part of your Cumulus workflows, for example, a discover granules task, which is kind of NASA DAC specific thing for discovering granules of data from data providers so that the ingest process can start. And then there's the Cumulus dashboard, is actually a completely separate repo. And later in the presentation, I'll have links to where you can actually find the code and the NPM packages and all of that. There are some examples of contributed resources. So there's this thing called the thin egress app. So once your data is in the cloud, once it's gotten there by Cumulus and Cumulus is aware, and it's also published out to other systems about what data it has, and they're coming into Cumulus via CMR or links from CMR or something like that, then we have an API. That's what they're actually being linked to. There's an API to actually pull down the data. It requires some authentication. In this case, it would be NASA Earth Data Login authentication, but it's just providing access to your files stored in the cloud. And the next example is specific to a process that some of our DACs use called the cloud notification mechanism, which is how they become aware of data that needs to be ingested, but they have this Lambda called the CNM to granule Lambda that they contribute. And then, of course, hopefully in the future, the goal is that as more people start using Cumulus, more people, including you, would contribute more functionality. And so this is kind of the goal of what we're trying to work towards. Again, it's the terminology on this slide is specific to the NASA DAC ecosystem, but we have different DACs, DACs A and B. We have the core tasks that are like the green boxes, and then DAC A is like a turquoise box of a task they contribute, and DAC B has the yellow box. And then what this is just showing is that each stack within their deployment may have workflows that use the core tasks from Cumulus and then may actually use each other's tasks that they wrote. And that's the whole part of the whole point of Cumulus isn't just for it to be your cloud management tool, but also to facilitate this kind of collaboration and hopefully efficiency. So then more specifically, how does some of the parts of Cumulus work? So we call it, you probably heard me say the word ingest, so we call it Cumulus an ingest and archive tool. It's ingesting your data into the cloud, and then it's maintaining an archive about what has been ingested and publishing information about that archive to external systems. So how this actually breaks down is that work is scheduled, and in this example, maybe the first thing that's scheduled is a discover granules workflow, which again is discovering data from a remote data provider. And then once it's discovered, that discover granules actually schedules some more work that runs some new step functions, AWS step functions. And that step function is what's going to actually sync the data, maybe do some processing on it, which is usually going to be something that's written by the Cumulus user themselves, again, because Cumulus core couldn't possibly predict all the different kinds of processing different data managers would want or need to do. But then at the end, there might be a step to submit to CMR. And once that's all done, Cumulus then has, of course, the data stored in the S3 buckets on the cloud, and then it's possibly also published out to CMR so that people can come and find this data. And then that's, again, the bottom right is the distribution API, which actually allows people to access the data that's protected in the cloud. So they have to authenticate with, in this case, Earth Data Login to get access to their data. But there's also some of the functionality, again, that's built into Cumulus that's useful. So ingest failures. So, you can configure, since workflows, when we talk about Cumulus workflows, we're talking about AWS step functions that are composed of Cumulus tasks, core tasks, and contributed tasks. You can configure your retries, you can configure branching logic. Cumulus also has Lambdas that will automatically be triggered to log what the status of your executions are, so you know when things have failed or succeeded. But there's also failures to trigger ingest. So for some reason, work was scheduled via an SQS queue and then it couldn't be started for some reason. Then it can go to a dead letter queue, which will then get reprocessed. And so it's not like work that you want to happen is just dropped on the floor and then never thought about again. It will be attempted to be reprocessed later. And then mentioned data provenance earlier. So each piece, each task that would be running as part of a Cumulus workflow is versioned so that later, if you need to recreate that same workflow, you can configurably recreate the same workflow with the versions of the packages, the tasks in that workflow. So which gives you, security about knowing how the data got there in the first place and being able to recreate that specific case as well. What is next for Cumulus in terms of things that we're going to be working on as the core team? So I've mentioned this concept of Cumulus as an ecosystem a couple of times. So we want to make the contribution of experience, of course, even better than it already is, and just make it as easy as possible for people to contribute. We are going to move from our current deployment tool to using Terraform, in part because we think it makes module-based deployment a lot easier when people have these different pieces. When we talk about Cumulus deployment being composed of different pieces, we think that Terraform module-based deployment just makes that process of configuring your deployment a little easier to follow. And then a solution for hosting those contributed artifacts. So, in some cases, there may be concerns about not wanting the artifacts that are contributed to be fully public or something like that. So we're trying to figure out how to accommodate those sorts of things while also, again, hopefully achieving the goal of reuse. And then the developer and user experience. So these are just some niceties that we're going to work on. So we're going to be setting up SNS topics for ingest completion so that you could subscribe to that and know very, very quickly, very immediately when things have completed. If you wanted to write something about that data yourself to some other process internally, then again, we can't predict what you might need this for, but the goal here is that we want to provide some clean interfaces so that you could do something that we can't predict. So like this is an example of just setting up an SNS topic that tells you that data has finished ingesting. We want to reduce some of our dependency footprint and just make it generally lighter weight where we can. And then specifically, there's going to be work on the dashboard, which we'll show in a minute, just on the user experience and some design improvements. So again, where is Cumulus? So this is the actual repo for the open source for Cumulus core up there in GitHub. That's our documentation. And then if you want to specifically browse the packages, they're there on the npm.js. And I do not want to update Java right now anyway. Okay, so we can now move over to the live demo. Let me check and see how we're doing on time. Okay. Before we jump into the live demo, there's a couple of concepts that are beyond. So we talked about the Cumulus deployment and what it's composed of and what it looks like when it's actually deployed on AWS. But when you're then configuring Cumulus as an operator and trying to set up these ingest workflows, there's a few tasks, or there's a few concepts rather that you need to know. So provider, I've mentioned this a couple times, and this may be familiar to a lot of you, but just in case, providers generate and distribute the input data that Cumulus obtains and sends to workflows. So Granule, it's the smallest aggregation of data that can be independently managed. It's a grouping of data files that are inherently interrelated in terms of understanding each other. Then a collection is a logical set of data objects of the same data type and version. So we have collections of granules in Cumulus. And then rules. Rules are how we actually start the processing and transformation workflows. They can be invoked manually, on schedule, or like I mentioned before, via triggers, Kinesis SNS. For our demo, we're just going to show manually because that's the easiest to set up. Well, not questions yet. Now we go to the demo. So before we do that, that is way too small. Let me make that much bigger. And even bigger. Okay, so this is a configuration file for a Cumulus deployment. I'm not going to go through all of it in detail because again, there's a lot of things you can configure that for the purposes of this demo you don't need to necessarily. But so in a Cumulus deployment, you will configure your S3 buckets and you will name them. So you'll have an internal bucket, a private bucket, a protected bucket. And this will come in later. We'll see when we're configuring our collection to determine where we want data to go when it's ingested. We'll be able to specify we want it to go to the internal bucket or the protected bucket. And based on which bucket it goes to, that determines how it can be accessed. So for the protected bucket, you would have to come through the distribution API and log in, for example. So this is where you configure your step functions, and those are also just YAML files. Again, I mentioned VPC support earlier, so there's all these different aspects of a Cumulus deployment. And if we want to take a quick look at what the workflows configuration looks like, So we have, let me just make some of this smaller. So we have like a discover granules workflow. These are all like test workflows that we have in our Cumulus core repo so that we can, of course, run tests against them and make sure that they all work properly. So it's just general YAML. This really is just general AWS step function definition in YAML. So we have a first step of this workflow that's a status report, which is what's saying like I'm about to ingest this data or try ingesting data, running a discover granules Lambda function. So again, this is when we start talking about that you have this piece is provided by Cumulus core. This is a task provided by Cumulus core that you would use maybe as part of your workflow. And then this workflow, after it discovers the data, discovers the granules, then it's going to queue them, send them to a queue. And again, it's clear that you can configure what queue you want. Don't focus too much on this kind of syntax for where the data is coming from, but you can specify what queue URL you want to use. You can specify what workflow you want to be run on the data once it's queued. So what workflow should we trigger, which we'll see later what we're going to do with that. And then the provider and the bucket and everything. And then this workflow is pretty simple. Then it just stops. So it just discovers data, queues data, and stops. So we're going to show actually interacting with using a rule to run a discover granules workflow. Okay, so now we can jump over to the dashboard. Not that. So first thing that you probably want to configure when you're setting up a new ingest for Cumulus is your provider. I've already done this, but we'll just walk through what it is. So the name, the provider name is, again, it's pretty much up to you, and just give it a kind of arbitrary name. This provider is HTTPS, so we support HTTP, FTP, FTP, or S3. So you could be ingesting data from some other S3 location. Then the host, just the domain, and then all these other options if you need them. But in our case, we don't. It's just it's a public set of data that's provided by GHRC DAC. This is actually what it looks like. If we want to, I'll make that much bigger. We'll come back to this a couple times as we explain how different pieces here work. So yeah, but generally speaking, the most important thing from the provider here is just you know, what's the protocol and what's the host and all of that. So once you've set up the provider, that's usually pretty straightforward. Then you go over to setting the collection, and the collection is how we're going to again identify what are the granules in Cumulus parlance. What are the granules of data that are contained from this that we're going to ingest, and how should we handle them? If I go and edit, the experience of creating and editing collections in Cumulus is you actually edit a JSON blob here. And let me make that also bigger. So again, you name it, your version and data type, and in our case, I just made it up because it's an arbitrary data set. You actually configure the path on the host to the data here on the collection. So that's what this is. Duplicate handling is kind of another built-in feature of Cumulus. So maybe you've processed this data before and you want to process it again. And so what do you want to do when you find that duplicate data already in the cloud? Do you want to replace it? You can also say you want to throw an error, you want to skip it, or do you want to version, meaning that the new data will be versioned so that you have multiple versions of the data. And then we start getting into the configuration. Okay, so we have all this data here over on this provider, and how do we identify what the granules are? So a word of honesty here, I don't, you know, as a Cumulus developer, I know very little about the earth science data itself. So this is just a nice public data set that I thought would be useful for a demo purpose because it's pretty small. But let's assume that since we have files that are named like .6 and .6 text, that they're actually related. And so how do we want to be able to extract a unique granule ID for these file names that are related so that we can determine which files that are discovered are related. And so that's what we're actually doing in the collection configuration. So how do we extract this TMT DAY ACZ 8110? Because the pattern is pretty much the same. You have files, sometimes you have a text file, sometimes you don't, but you want to be able to determine what the unique granules in this listing of files is. And so that's where regex comes in. Is okay, granule ID is going to generally follow this regex. The double slashes here and some of these regexes are just for escaping reasons. So then how do we extract the granule ID? This is the first part here is what's going to be of this statement here in the capturing group of the regex is what's going to be the granule ID, and the second part here is just the different possible file extensions. EMS isn't so important right now, but then sample file name. So when you're creating a collection, you give it a sample file name, and when you create the collection, it'll validate that your regex actually works for the file name that you're putting here as a sample. And then this is what I mentioned before about different buckets. So we have the public bucket and protected bucket and protected to bucket, and that goes back to the Cumulus configuration that we saw before about, okay, we have an internal bucket. So you just have to specify in your collection that I want the internal bucket, and it'll know to use the bucket that you care about. And so then you have these different regexes for the types. How should the different type of files that might be encountered be handled? So I'm saying in this configuration that the files that just end in the .6 extension should go to the public bucket, and that's the regex for defining them. The files that end in the .6.text extension should go to the protected bucket, and then this is a CMR file that might come in later in the demo if we have time. Okay, so once you've configured your provider and your collection, then you're ready to configure a rule, which will allow you to actually run a workflow, which is probably what you care about the most. So go here to the one I've already created. And again, this is going to be a JSON. So again, name it whatever you want. And then here you go, you specify the workflow that you want to run. So discover granules. That name matches directly to the workflow name that I have here in my deployment configuration for the step functions. Then you have to specify the collection, both name and version, because you may have collections that have the same name but different versions. The provider, so just the ID of the provider. And then in this case, it's very simple. Rule is just type of one time, meaning it's going to be invoked manually. Again, you can also set up, I don't have examples of this for the demo, but kinesis triggers or SNS triggers, and then make sure it's enabled. Okay, so now let's actually do the thing. Let me click on the rule, and here in the dashboard, when you first create a rule, it runs it, but also you can then rerun it if it's a one-time manual invocation rule. So I'm going to rerun it, and then things should start happening. So I confirm yes. Then I'm going to go over to our executions page here in the dashboard. You'll see a bunch of things that failed from me testing this for the demo. But in a minute, we should see our discover granules execution workflow show up here. It will take possibly, and so there we go, it just showed up. But it can take a little bit because this work is actually being scheduled itself on a queue and then picked up by a Lambda consumer off that queue. So there might be a few second delay after you've triggered it before it shows up. But okay, it's running. So now I can click on it. It's probably already done, which it is. So we have this execution, nice execution page where you can see information about it. There's a nice graph there, which I'll show in a minute, pretty much resembles exactly what you see on the AWS console, and then all sorts of information about it, the execution ARN. You can get access to the logs, and then you can look at the different actually input and output to each step. So you can see the whole message that was passed between the different steps of the workflow. But let me actually also show this on the AWS console. Let's discover granules state machine, which this looks like the one that I just ran. So you can see all good, all green, pretty much the same sort of looking graph of the execution from, this is all, you know, AWS step functions. So if I wanted to be able to look here at what the input and output from each step is, I can do that. Actually, in this case, this is something Cumulus does for you. If messages get too large, Cumulus will automatically store them remotely on S3, and then there's the message you see here in the console is just a reference to, hey, you need to look up this on S3. But that's where the dashboard becomes really useful, because it will actually show you it will actually retrieve the message from S3 and expand it, so you can look at it there. So if I want to look at the output from step 10 when discover granules succeeded, I'll go over here and go click more details. And the Cumulus message that's passed around has a fair amount of metadata that is useful between steps. So it doesn't just have the payload that's passed, just to make it easier. But we can go down and find the actual payload. So the payload from discover granules is just an object, or an array of objects rather, of the granules it discovered. So you'll see the first one it discovered is this granule ID named TMT day 5. So then if we go back to our data provider, is that a granule ID that we would have expected? That makes sense. And the answer is yes. So this first one here at the top is TMT day 5, and it has the two files, the .6 and the .6 text extension. And then it goes on. I'm not going to go through all of them, but then it's initially mapping what bucket these files will go to. So like we configure our collection, the text file should be going towards the protected bucket, and the other file would just go towards the public bucket. And then the Q granule step, which was step 15, go look at that output. Just to show that what it's doing is kind of a fan out pattern where it's going to be scheduling a bunch of things to a queue, and the Q granules payload is just actually listing out what were the different executions that were scheduled. So if I actually go over to that state machine, the ingest granule state machine, you should see a bunch more. And also just to say, the ingest granule state machine, I know the name here has a bunch of other, it has a prefix for my stack, and it has an alphanumeric identifier here at the end, but this part, ingest granule, maps back to, in the discover granules configuration for the workflow, we said that when the executions are queued, that we want them to use the ingest granule workflow. So that's what it's doing. And then we can also, of course, change that. That's why it ran this workflow. And also we can go back to our dashboard and the executions page, and those executions that were scheduled and ran will also show up. So you can see they're all showing as completed. They're the ingest granule workflows. So just everything here is showing up as it should. So we can get all this information. I think it's showing the wrong graph, but anyway, we can get all this information about what was ingested, and we can get the same thing by going back again to the console, just showing that the dashboard does have access to the information. But here, if I view it, we can see this workflow is a little bit more involved, has a fair amount more steps. It syncs the data, and then it optionally does some processing and moving of data around. But the main thing is that this is the workflow that's actually pulling the data into the cloud, not just discovering it and queuing it, but actually getting it into the cloud. So yeah, at the end of this, we should, since this ran, ran successfully without any issues. We should actually now see the data in S3 where we'd have expected to see it. So if I go over to my public bucket and I refresh, you can see these TMT files with the .6 extensions, and we're only seeing the ones with the .6 extensions. So that's all working properly. Well, I guess this was left over from when I ran it earlier, but here in the protected bucket, we're seeing the files with the .6.txt extension. So again, things going where they should go. And yeah, that's pretty much it for in terms of running an initial basic workflow via a rule that schedules other workflows. That's kind of showing you the baseline of functionality that Cumulus provides. We can also, well, I'm going to try, so this is going to be the live demo. This is, I've obviously ran through all of the rest of this before, but I want to show also, if possible, that you can then publish information about what you've ingested out to systems like CMR, and then people will be able to find it and access it. So I'm going to try this real quick, and just to kind of give you a flavor then what it looks like if you want to say, okay, the discover granules ingest worked fine. Now I want it to do an ingest and a publish. So in this same file here, this was the ingest granule workflow. I have collapsed, but this was the ingest granule workflow that we were running. We also have one called ingest and publish, and the main difference is just really that near the end, it has a step called the CMR step that actually does post to CMR. So I'll go here to my discover granules workflow configuration, and we'll do ingest and publish granule. And then I'll save that, and then I'll show the deployment real quickly, though it's not too critical. It shouldn't take too long because this is a small deployment. While that's running, actually, it's a good time, something I didn't talk through earlier. When we talk about the Cumulus deployment, it's composed of a couple stacks and a couple of nested stacks. So you have an IAM stack, which has different IAM roles you need for running your Lambdas. And then you have a database stack. So we decided to separate the storage, the persistent storage, the Dynamo and Elastic is what persistent storage is used in Cumulus. We decided to make that its own stack entirely because we want people to be able to delete their application code part of their stack and not have to mess with obviously their persistence layer. So that's its own stack as well. And then the last stack doesn't have a suffix, it's just the name that I gave my stack. And this is what contains all the application kind of code that Cumulus runs. And it has some nested stacks, just partially because of resource limits in CloudFormation, that you can only have 200 resources per stack, I think. So we have a nested stack for our back-end API, which is the API that the dashboard interacts with. And then we have our distribution API, which is how you access the data once it's stored in the cloud. And then we have another nested stack, which is mostly just kind of for internal use. So this shouldn't take too long, hopefully. But obviously, you can come in here while this is running, and you can look at the events for people who maybe don't have experience with CloudFormation. Looks like it just finished, but you could come in here and see the events and what was happening, and inspect any problems you're having. So yeah, it finished, and now Cumulus is doing some, our deployment tool rather, is doing some post-deployment steps of updating some workflow templates. So that is almost done. So then if I go over here to my rule, now when I run this rule, it also will run a discover granules workflow again, but the work that should be queued and scheduled is work to, again, do an ingest and a publish, not just an ingest. Just waiting for that to finish entirely so I don't put anything off. Okay, there we go. So let me come in here and again, rerun the rule. Yes, confirmed. Go over here to the executions tab, wait for that to show up again. Again, it can be, it showed up real quickly earlier, but it can be a bit of a delay while things are scheduled by queues and read off by Lambda consumers. So let me close some of these, see if it might take a second to show up. Come on. It was so fast earlier, we were spoiled. Distributed systems. Well, don't think it's going wrong. I'm going to wait a little bit longer before I assume something's broken. There we go. Cool. Showed up. Sigh of relief. So there's the discover granules workflow running. It'll go very fast because it's just discovering data and then queuing it up. So it's just about done. It's just on its stop status, which is just reporting information about the execution and storing that in our database. There we go. And then again, there will be a delay between when this finishes running and when you actually see those other executions start to show up, because they're also scheduled and read by a consumer and yada yada. But instead of it being this state machine with the ingest granule state machine, it will be the ingest and publish granule state machine. So I did test this earlier, which is why you see some failed executions, but I tested it yesterday and such, but I was having some issues with CMR that were not my issues. They were not CMR issues, they were my issues in terms of my configuration for just this demo. But I think I may have resolved that so that it will work. So we'll see. If not, there's other things about this that we can talk about. So let's see. Okay, well, they are running now, so that's good. If I refresh here, you'll see that they're running. So it's on the last step. It's very similar to that ingest workflow before. It's syncing and then doing some moving of files and then posting to CMR, hopefully if it succeeds. So before it was failing. Let's see if this time it succeeded. Again, it's the live demo. No, it did not. So that's just, again, this is my issue with not having created the right thing in CMR, but that's totally fine. I mostly just wanted to show how you configure Discover granules to run different workflows. And even though that didn't work, I can kind of show you what it looks like when it does work. So this is an example of a document in CMR. I mean, I know it's just a blob of JSON to look at, but this is an example document in CMR from when something was ingested successfully. And the main thing to note here is that it has different links for different type of files. So let me make this bigger, actually. So for a public file here, there's a public AWS S3 link to download it, because based on the configuration for this collection, when this was ingested, it specified that this file was public, and so if it's in the public bucket, that's how the access to it is handled. But then we have an example here, which is just implemented with an example.com distribution domain, but in reality, it would be our real distribution API URL, and then it links to that file. And same here with, in this case, an HDF file that you would access. So those are examples of real CMR documents that were created by Cumulus. But even though our CMR step in the workflow I just ran didn't work, I can show you downloading one of the files that's in protected bucket just manually using. Normally, people would discover these links via CMR or via some search tool, but I can also just kind of create one manually. So if I go, actually, one thing useful that our deployment tool does is publish or tell you what your API URLs are. So I'm going to copy that for our distribution API. And then I'm going to go to a file here in the protected bucket and copy the path. And delete the S3 protocol there at the beginning. All right, and run this. And this, again, is a protected file, so it should send us over to, in this case, what we've configured is Earth Data Login as the OAuth provider. So it should send us over to Earth Data Login, so we have to authenticate and then be redirected back to get the data. Yes, so it's redirected me over to Earth Data Login. I'm gonna get my credentials, and then it should redirect me back. So in most cases for larger files like HDFs or whatever, you would just get, a streamed download, but for this text file, it's literally just printing the output to the screen. But regardless, that's the data and accessing it via the distribution API. And part of the reason why the Earth Data Login is required is so that in the username and the redirect, we can track, again, who's accessing what data, which is often an important thing for data operators as well, tracking your access and who's using what data and whatnot. I should also mention that the OAuth implementation, we're using Earth Data Login here as the OAuth implementation. It also Cumulus also supports Google OAuth out of the box, and of course more could be added. This is just going to be to show that if the CMR step had worked, so we have our collection here in the Earth Data Search UAD environment, our demo collection, and if it had worked, then our granules that we ingested would have all appeared here under the collection in Earth Data Search. But then other thing maybe just to show on the dashboard before we wrap up here is the granules page, which is just telling you what has been ingested. Oh, they're all showing as failed because I just tried to rerun that ingest and publish, and that failed. So it's reporting that these granules are in a failed state, but before they were in a successful state. But regardless, we have this different information about them. We have the granule ID, what collection they're linked to, the execution. This is all just easy to click and access here. The execution that is linked to this granule, and if I click on the specific granule, if there was a CMR link, it would appear here, right here, and the provider and the different files and where they are, what bucket, and links to them. So yeah, that's pretty much it in terms of that. Also, some things about the dashboard. A lot of these terms can be localized. So like these concepts of collections and granules, maybe, you can rename them to something more generic if you want to, if that made sense to you in terms of configuring the dashboard and deploying it. But let me see. I think that's pretty much it. So I guess I will just stop there and open it up for any questions. The reconciliation reports tab. Yeah, so I think you were just asking me to show the reconciliation reports tab here in the dashboard, which I didn't demo at all. Yeah, so the reconciliation reports tab here is another feature that's kind of built into Cumulus. So the possibility is that your internal storage in Cumulus in our databases could become out of sync with what a system like CMR or something is aware of, and so you may want to reconcile so okay, I know that as in our Cumulus deployment that we're aware that we've ingested this data, but CMR or what have you is not. So we can create a report. It's obviously just a pretty simple page here in the dashboard. And just click the create a report button. I can do it. I have no idea how long it will take to run. So I can just click it and it might take a while to show up. But anything else? What?
porting this to work on a non-AWS platform?
So there's some initial exploratory work going on around that. I think the approach is going to be rather than trying to port the existing Cumulus core code base to run on Azure or GCP, maybe re-implement the same functionality, because obviously, as you saw, step functions are at the heart of Cumulus here in their workflows, and so exactly paralleling that on a different cloud platform will require slightly different implementation. So yeah, there's some initial work being done on that, but Katie, looks like you have. Katie.
I work at NASA. Sorry. Yeah, I don't mind using the mic. So I think there's several efforts. The question is whether it makes sense to look at other commercial cloud vendors' step function replacements or look at more vendor agnostic tooling. We did I guess a hack fest, like 6 months ago or something, to look at. So to answer your question, there are no solid plans through ESDIS, the organization I work for, to move Cumulus out of AWS. There are other players, because it is an open source tool, who are looking to engage, as far as I know, with other commercial cloud providers. There's also a second effort going on that is very much in its infancy and it's driven by these like vendor agnostic requests that are not specific to another commercial cloud provider, to investigate using an open source workflow management system, like I guess Conductor or Airflow, is that what it's called? Yeah, so there's a lot of workflow engines out there that are not tied specifically to a platform. No work nor funded plans to work has occurred yet, but I would not be surprised to see something in that direction over the next 6 months. Does that answer your question? Okay.
So can you throttle workflow control based on the cost? So if I set $1,000 for workflow processing, if it reaches, it stops, like that?
I don't think so, but I'm going to defer to our architect, Patrick, who's here in the room.
The answer is no, that you can't do it at that level. We do have cost controls in place, but that is more at the AWS account level, where things will cut off if they start getting too expensive.
Question has been about the role of the data providers using Cumulus to inject data. What's the schedule for data consumers as to when the data that's ingested in Cumulus will be accessible, and how will that work?
I'm not sure I totally follow the question, but it seems like Katie has an answer. So
it's specifically outside of our sphere of concern. I mean, this is an ingest archive distribution system. So if the distribution engages with services that are provided by other services, that is sort of on the other side of the fence, at least right now. But is that what are you talking about when people go operational, or are you talking about what the role of Cumulus is in enabling services?
In the end, the data will end up in the S3 bucket. And as data consumers, I may want to access that data from that bucket directly. So I guess what's the rollout, and what will be the process of accessing that data?
I'll let you answer first.
So like Mark showed, he showed the file in CMR pointing to the distribution API. Mark can you bring up the CMR file again? Okay, so we have the links here. Some of them are public, so they're going to go directly to S3. Some of them are going to be behind the distribution. That is all configurable. The other thing that Cumulus deploys out of the box is direct S3 access. So I think if you scroll down, you'll have the S3 credentials. So you're able.
This is an older one.
This is an old one. Okay.
So it doesn't have it.
You're able to get hit an endpoint in your distribution API, get credentials to access the files directly on S3 in region, since that is pretty much free if you want to do that kind of processing. And then in terms of the discovery of these, Mark had up the Earth Data Search client that he was using. So like he said, under here, you would see the granule files under this collection, and that's how you would discover those links, whether they be hitting the S3 bucket or CloudFront in the future, or the distribution API, or you could get the direct S3 credentials to use in your processing application.
Yeah, just quickly to show, this is, I guess I could have showed this earlier for for the one that we do know that worked previously. This is, I'm just going to look it up by the collection ID, and it has a bunch of granules because this is what we use for testing. So it's not a real world example, but has a bunch of examples here. And then if I wanted to search for this granule specifically inside, I can go inside the collection here, and there it is. So that's what it would have looked like if the post to CMR step had worked when I demoed it.
So that mechanism is already in there. It'll be available when DACs choose to publish it with it, which I think our first one should be operational September, October-ish. The other thing to note is I think we've been struggling a little bit with the actual utility of the S3 API access, because ultimately when you follow the link to the data, it's just giving you a pre-signed URL to data in S3. And if you are, coming from a cloud, like if you're coming from the same region in the cloud, you will get unfettered access to that data as though you're going through the S3 API by just hitting the HTTP URL. So we do provide the mechanism, but it's a little questionable. I guess time will tell how many people actually choose to use it, given that there's no real practical difference to using the S3 API versus just the HTTP links.
If I wanted to do, say, S3 range gets, I'm not sure you can do that. Okay.
So do you have any performance showcase example? How many granules you process and in how many time, in what amount of time you finished, and how much it costs? What is the largest collection you process with Cumulus by DAG or as an example?
So I'm going to let Patrick answer that as well, because again, as a developer, I don't have a lot of insight into the DACs and their operational loads that it's been put under so far. So.
Yeah, so in terms of real data, we've ingested, I think at this point, most of the GHRC holdings for their DAC, and they will be completing that soon. We have, though, in preparation for upcoming missions, particularly SWAT, there's been load testing to establish that we're able to handle the volume of both file size and granular rate that will be necessary for both forward processing of that and ongoing reprocessing, and found that there was no particular issue. So I don't have the numbers off the top of my head. I want to say it was in the tens, if not more, thousands of granules a day with several terabytes flowing through.
And did you cost model that?
They cost model that, I Cost-wise, though, in all the cost models that we've done, the actual cost of running Cumulus or any sort of computation gets dwarfed by the cost of actually storing the data or egressing the data out.
Cool. Well, if there's no other questions, I think we ended 11:45. But before we do, can just the members of the Cumulus core team who are here raise their hand besides me? So if you want to, if you see us in the hall and you want to ask us more about Cumulus, please feel free to do so. And also, if you want to try it out yourself, this is the repo where you start building your own Cumulus that you clone and start building your own Cumulus deployment. So if you want to try it out, feel free. It'll point you to the Cumulus documentation and the steps involved to do your deployment. So cool. Well, thanks everyone.